Good afternoon. Notice that this continues the previous sampling lecture/video in the color scheme, in the numbering, and in the theme, sampling. So in the first lecture, I provided all the basics of sampling. Now let's look at the two basic types, each of which is broken down into 4 subtypes. So let's do a little repetition. The chance of any element being selected is calculable in probability sampling. You're able to calculate. You're able to say you have one chance in 1,000 or one chance in 100 or one chance in 325 million. So if you're going to get a sample from the United States population, you're going to want more than one person. So that's the definition of probability sampling. Anyone find it weird that we're talking about people as elements? I hope you find it weird, but I'm going to keep doing it anyway. But let's focus on the fact that almost always in sociology, we are selecting people. But you can calculate because you have a sampling frame. Here's the point in the semester where I look at the students and say, okay, define probability sampling. And invariably, and it's like 3 semesters in a row, they've looked at me and just kind of stared and said, so I'm telling you that to really emphasize this. Probability sampling is the chance of any element being selected is calculable. Know it, remember it. And to do that, you have to have what? A sampling frame, a list of all the elements in the population, in the target population. Remember, you define a target population, you say, I want to study these people. You have to say that up front. Who are you trying to study? And then you get a list of all of them. A good example would be the registrar's office. If the law didn't stand in the way, and it should stand in the way, but if it didn't, you could do a census of every Illinois state student. You could just go into the registrar's office, but FERPA, Federal Education, I forget something Act, keeps all of your records private. So we can't even sample, much less do a census. Okay, how it's done, it's random. That's really crucial. Again, I'm just going to repeat it. It's random, which means C, you're reducing bias or you're eliminating bias. You're never really sure. There's always sampling error, but you're reducing bias. Bias is overrepresenting a population characteristic or underrepresenting a population characteristic because you want the sample to look like the population. Okay. Okay, principles. These 3 points. The larger the sample numbers, the more confidence we have about the representativeness of the sample for the population. Remember the last time I said you could choose 100 people to represent the US population. And you can do really well on race and ethnicity. So you got 1 person who's Native American and 6 people who are Asian American and 13 people who are African American and 18 people who are Latin American, Latinx, and everybody else is white. That's the racial ethnic breakdown of the United States right now. But if we start adding other categories, which we have to do, we might not get everyone. If we have a sample size of 200, now we can get 1 male and 1 female for each race and ethnicity position. We're still missing intersex people, we're still missing trans people, but we're a hell of a lot closer. If we get to 300 or 400, then we can also really begin to be confident we're catching social class and ethno-racial issues and gender, and maybe we're going to start picking up intersex or trans people, and homosexuality. We can really start getting into the intersectionality of categories that actually exists in the population. The larger our sample, the more it looks like the population, which is representativeness. Okay, increasing sample size is better than increasing the percentage of the population sampled. So, I mean, wouldn't it be great if you could go from like 0.1% to 1%? That's great. Well, no, actually, don't shoot for that. First of all, that's a pain because it's incredibly expensive. And second, just numbers are better. So in the example I just used, if we go from 100 Americans to 400 Americans, we've really improved our representativeness. But the percentages have barely budged. I mean, 100 people out of 325 million or 400 people out of 325 million. The percentages are vanishingly tiny either way, but just by adding numbers, we've greatly increased representativeness. So just focus on getting more people. It's all, as I said, sociology, people. If you're doing biology, animals or plants. So the more homogeneous the population, the more everybody looks like everybody else, the more confidence we have that the sample represents the population. You're just not going to be missing categories. You're not going to have a large sampling error. By the way, for number 2, I want to go on a little mini rant because this matters. In Maria's report, yes, I am actually starting to grade exam 2. And yes, we are not going to have 3, 4, and 5. You can relax about that. I don't know what we're going to have. We're going to either have 1 more paper or 2 more papers, and I know what you want. But I'm going to put out an email asking about that and see what you guys think. But first, let me get exam 2 graded because it's been ridiculous. I mean, the situation is ridiculous, which is why I haven't finished it. But anyway, so I read Maria's report to make sure I'm doing a good job grading your papers. And a lot of students in the major say, we don't need to know research. You know what? You need to know how to consume research. I said this before. I had a whole day that argued. We've been using research for over 200 years, research on people, just to read the damn papers and know how to vote, know who to trust. You should have research skills. You should know the basics of social research. So political polls. How do you trust the polls? How do you know that people want Bernie over Biden, or really they wanted a woman, or really blah, blah, blah? Doesn't matter. How do you know that 40% of the population thinks Donald Trump is the second coming of Christ, which they seem to do? Look at the research procedures of the pollsters. They use social science methods all the time. Also, and I'm going to talk about this again, notice the response rate in Maria's report. You guys and people who come before and after you didn't really respond all that much. The response rate was really low compared to what it could have been. So how do we trust Maria's report, or Maria and her students' report? The response rate was so low. You know what? It was something. But response rate, I just want to point out, really matters. Okay, rant over. Okay, the 4 types. There are 4 types of probability sampling. The first decision for your paper, because you will at least have 1 more paper, is do you propose to me probability sampling or non-probability sampling? The second decision is which one of these 4, once you've made that first decision. I mean, it's a flow chart. You know, first you have this decision, then after that decision you have 4 more others, 4 choices within the next decision. Simple random sampling, systematic random sampling, stratified random sampling, and cluster sampling. Which one? Okay, simple random sampling is as simple as it sounds. You just generate a random number table. You go to your sampling frame. You just pick those people who got picked. They are now, you've turned them into numbers, and now you just take the numbers and apply them to your sampling frame. And that's your sample. Easy. Um, Systematic random sampling. It's kind of a cheat because part of the definition of probability sampling is you need a sample frame, and this says you don't need a sample frame, but you need a list, or at the very least, you need numbers. You need a count of the population. You need to be able to know how many people are in your target population. And then what you do is you pick the first case, you pick the top of the list, or whoever you run into first, and then every nth case, so every ninth case, every 10th case, every 100th case, whatever it is. Sorry of those of you who were traumatized by algebra by using nth case, but you get the idea. So it's, I don't know, sampling frame-ish account. Okay, the problem, I'm not impressed by the example in the textbook, the northwest corner of the block. I mean, come on, man. An example I think would be great from demography is that year after year, and this is true around the world, this is not true just to the United States, year after year, they see the birth rate goes up over the summer in the northern hemisphere and drops in winter, which means people are conceiving babies, well, you know what that means, in the winter. So people are conceiving babies a lot around Christmas because the babies tend to be born in August, late August. So suppose you, God bless your pointy little head because you're blowing it, whoever you are, I'm not picking on any particular student, but let's say researcher X goes out and says, I'm going to make sure that everybody, all birthdays are represented equally in my population. Okay, this person is ignoring the periodic influence, seasons. People are born more or less depending on the season. I mean, the numbers are high even in winter, but they're higher in summer. So you're oversampling in the winter and you're undersampling in the summer. Don't do that. You've got, and the thing is, I'm just using births, and should in the textbook used, what's the word? He used, yeah, residences. It'll always depend on your question. Sexuality, policing, schooling, whatever you choose, you've got to make sure there's no periodicity, no periodic influence to throw off if you use systematic random sampling. Okay, somebody had a question by email about stratified random sampling. And strata or stratum, which is singular, strata are plural, Latin plurals, into science vocabulary. A stratum is, excuse me, a geologic metaphor from geology. It's layers of dirt, layers of soil. And you dig down and you get through different layers, different strata. So it's a metaphor because, so with class, I've got an example here on the screen. That kind of makes sense. The strata are by how much wealth or how much income. That's almost always when you're looking at economic inequality. It's either income or wealth. So you start at the bottom or you start at the top, meaning the people with the least to the people with the most, or vice versa. Since it's numeric, there's more and less, you can say above and below. I don't like using stratified as the metaphor for random sampling when it's race because, okay, then some are more and some are less, and like, ew. So you get the idea. But this is the language we have. What you're really doing is dividing your population into categories and then sampling within each category. Think of it that way. So a variation would be proportionate stratified. So my example would be Nigeria. Let's do religion. That's easy for Nigeria because there are three basic categories. Islam has been in that region for about 800 years. Christianity came with the Europeans in the 19th century. So a good chunk, probably the majority of Nigerians are Christian or Muslim. But the third category is traditional African religion, and that's, that varies across the country because each small group has its own practices, but there are commonalities across these groups. So and this number is fictional, but let's say 40% of the population is Muslim, you make sure 40% of your sample is Muslim. If 20% of the country is Christian, you make sure 20% of your sample is Christian, and so on. That would be proportionate stratified random sampling. Disproportionate stratified random sampling means if you've got a really small subgroup and your numbers are so small, if you go with the normal sample, then you get like one person out of that group, you're going to miss any diversity in that group. So you oversample them, but then you reweight. So if they're like 5% of the population, and you oversample them compared to everybody else, you get a lot more people from their group compared to what their percentage is, 5%. But then you take your results and get them back down to 5% of the population. You use math. Yeah, I'm looking at my notes. Yeah, that's it. Okay, on to cluster sampling. Okay, cluster sampling is also kind of a cheat if you're not going to use a sampling frame. So in this case, what they're doing is saying that the real key to probability sampling is randomness, so that you reduce bias down to 0 or as close to 0 as you're able to do. The population is available, and yet the frame, the exact list, is not. So the most common example in actual research, social research, is geographic. So, I mean, I went on the web, but before this, I've used this exact example without going on the web to see, and it got confirmed. They tend to look at cities in a country. So the example I found on the web was Spain. You could use the United States. You could use Canada. You could use a state. A state is more problematic because most states have a big city and then a bunch of small towns and villages. And so if you were to use Illinois and Chicago's in your sample, oh my God, it's totally thrown off. Whereas if you use the United States and Chicago's in your sample, it can, kind of sort of in some ways, stand for LA or New York. I mean, you'd want a number of big cities and you'd want a number of small cities, etc. So it's multi-stage. A, you randomly select these natural clusters. You select some cities. B, you randomly select elements within those cities, which would be neighborhoods. So neighborhoods are zoned. I mean, cities are zoned. You may have noticed you got residential neighborhoods, and then you've got purely business-oriented neighborhoods. Sometimes they're industrial and lots of auto body and manufacturing, and sometimes they're just store after store after store. You don't live in a mall. The land around the mall is a parking lot, and then maybe there's a fence, and then you start the residential neighborhood. So you can find these clusters within each city. These would be residential neighborhoods or residential units. So then you would maybe sample those residential units randomly. And then maybe a third stage, you'd randomly sample houses or households in those neighborhoods. But think of cluster sampling as multi-stage, because it almost always is. Now, the sampling error is greater than with simple random sampling, but for so much research, sometimes you just do the best you can. So much research. Okay, non-probability sampling. Again, it's not calculable. You don't know. You just don't know the chance of any element being selected. You don't know. You're in the dark. Have you introduced bias? Probably, but maybe not. Maybe you've lucked out and yours is the one unbiased sample, but you don't know. Probably you've introduced bias, okay? More times than not. Do you know what the bias is? No, you don't. That's the problem with non-probability sampling. And I'm not going to say much about B. It's done lots of different ways. You have to get more creative, and they have. But I would say the 4 types of probability sampling are pretty creative. So when I say the purpose of non-probability sampling is just like, oh, I'm desperate, I just need some data, oh my God, that's not quite true. You can do very good non-probability sampling with results that probably do apply to the population, even if you don't really know whether you've introduced bias. There are ways to get around bias, and I'll be talking about them. So again, if you're going to use non-probability sampling, and chances are next fall, Maria Schmeckley is going to use non-probability sampling, even though she tried to get you guys to answer her survey, her qualitative survey, which could have been a census. They use non-probability sampling for the interviews. Once you decide if you're going to use non-probability sampling, then you've got 4 possibilities, 4 basic possibilities. So Sue Sprecher uses convenience sampling all the time. That's what anything on the web is. It's a convenience sample. Who's run across your website? Who's run across your survey? And responded. Again, response rate, which I'm going to beat to death because it's really important. So it's who you know or who you can get your hands on. And when I say who you know, I'm going to use Anna Morocco's research. I read her book, which was her dissertation. She and I went to grad school together. She is at Loyola Marymount, LA. And Anna did a book called Odd Couples, which was about gay, straight friendships. And she started with a convenience sample. She just knew people who she knew who were gay and had straight friends. And they divided into gay men and straight women. And that's kind of a stereotype. And the pretty insulting, I think I mentioned this in class, but I'll mention it again. The pretty insulting term for this is fag hag. And then lesbians who are friends with straight men, which does happen. And the name is Dyke Mikes. And, it's always the named person is straight in each friendship. She wanted to call her book Fag Hags and Dyke Mikes, and both her dissertation chair and her publisher said, you can't do that. So she called it Odd Couples. Great book. But she started with her friendship. She has a gay male friend and he has friends. And so she started with them. And so one way to get a sample is go online, put your survey out there, send an email to whoever you can. That's convenient. Or the people you know, like Anna did. That's convenient. And what Anna did then was snowball sampling, the next kind. Each informant identifies further possible informants. So the standard question, and you say it over and over when you're doing snowball sampling, is, do you know anyone else who I could talk to? That's the question. And I've actually asked students, which surprises me in Illinois. Some students don't realize you hold a snowball in the snow and you roll it, and that builds up and builds the base for a snowman or snowwoman. That's the idea. You accumulate as you go along. As you roll, you accumulate more snow. It's basically more interviewees. It's almost always used for interviewing. And that's what Anna did in her book. Interviewees. She interviewed people, and it's a very qualitative study. As I said, I read it. You say, can you tell me someone else I could talk to? Because people know each other. People who are like each other know each other. And they give you names, and then you go on to them and say, would you be willing to be interviewed? That's a snowball sample. The metaphor is a snowball. It's really good for hard to reach populations. Once you get one person, you can get into another person. Homeless, um, queer people who are still in the closet. There are still places in the United States where that is true. There are a lot of places around the world, Africa, Russia, other places, where people are deeply in the closet because they will be killed. So you ask, do you know anybody else? And they have to trust you. That's huge. Trust is very important to do good research and to find hard to reach populations. But snowball sampling is one of the classics for hard to reach populations. And the thing is, you don't know what the splits are in a population. If it's a hard to reach population, nobody's looked at it. If nobody's looked at it, nobody knows what it's about, except the people inside the population, of course. They know themselves. So your initial contact, maybe, there's two sides to this population and they all hate each other. They've divided over something that everybody outside the community has no idea, but inside the community, it's a big deal. And you've gotten one side and you're snowball sampling through one side. The other side won't talk to you. That's what I mean by D2C. Initial contacts may close off some element of the population. Okay. Quota sampling. This is like stratified sampling, but here you don't use a sampling frame. And the problem is, here, definition. Select elements so the sample represents characteristics proportional to the prevalence in the population. The problem is the word proportional. You got to know the population at least a little, so you have, this is kind of sort of sampling frame-ish. You need to know something about the population before you go into it. You need to know so many people are X, so many people are Y. Otherwise, you can't do quota sampling. And then you get a quota about a quota of each category. If you know it's 5% X and 20% Y, well then 5% of your sample needs to be X and 20% of your sample needs to be Y. And once you've done that, okay, you move on to the other categories in the population. You just get each and then move on. And again, the problem is you might miss characteristics of the population. That's a problem. If you don't know everything about the population, you might make a mistake. Okay, purposive sampling. This I've done and I've seen. I was a grad student. This was 1998, 9, 2000. I was on a study. I was the grad student, then there was a postdoc. He had his PhD and he was working for a year on this project. And there were two professors who were the principal investigators. And one of the principal investigators gave me this research assistantship. And she was then on two of my committees. She was great. She told me about this. So this was the California Institute for Energy Efficiency. And we were looking at developers, commercial developers, commercial buildings. So somebody builds an office building and then sells it and makes a bunch of money. Why weren't they building the newest energy efficiencies into it? They were finding out, the California Institute for Energy Efficiency was finding out, developers were ignoring new energy efficiencies. And they went to economists, and economists couldn't tell them. And so the sociologists told them, this is the problem. But how did we find out the problem? We did research. We interviewed people. And we purposefully chose various people. And as we went along, so, we started with developers. That's who you pick. I mean, in any industry, like real estate, commercial real estate, okay, there's developers, there's contractors who do the actual building, there's architects, there's regulators, government regulators to make the codes followed. We went with the developers first. Who are the people actually starting the project and managing everybody else? That was on purpose. That was purposive sampling because they were at the center. They were particularly knowledgeable about the issues. And when they talked to us, why did I put will talk? I don't know. when they talked to us, we learned a lot. Then we started talking about other people and they were able to help confirm. B is a really good principle for non-probability sampling. This is one way that you know you're doing a good job and that your results possibly are generalizable to the population from your sample. You keep interviewing until you get what's called saturation. You hear nothing new. You do an interview, I've heard literally everything. As long as you keep hearing new things, things that surprise you, things you didn't know, you keep interviewing. The first time you do an interview, and don't go beyond it, the first time you do an interview where you hear literally nothing new, you knew it all because you'd heard it from everybody else, you stop interviewing. That's a good way in interviewing to get pretty good representativeness. You actually probably have learned all there is to learn about the population, even though you're sampling. Okay, two more issues. First, when you write it up, you have to tell everyone what you did. You have to say, I used probability sampling and I used this particular thing, or I used non-probability sampling and this is what I did. And like in the last example, you would say, okay, I used purposive sampling and we went until data saturation. But you have to tell people in your report, in your article, in your book, how you got your samples so they can look at your research critically and say, oh, you're going way beyond your sample. Or no, you're really being careful. Good. You're going with what your sample is able to tell you and you're not overstating the case. Good. Or as I said, bad. But this is part of the publication process. Also, and I've said this before, and yes, I'm beating this to death, non-response rate really is important. It's really, if you don't get a good response rate, then you have to be very cautious in understanding, in generalizing from the sample to the population. One of the classic things in survey research is some people don't want to be researched. They don't want to be surveyed. They just want to hang up. I mean, more and more people do that. The population is getting or feeling, certainly feeling, over-researched. So, I mean, how many surveys a day do you get? Students tell me all the time they get a survey a day. Like, answer this survey. And what's your default response? No, I don't have the damn time. Forget that. You're part of the non-response rate. So they're relying on people who do respond. And what do they look like? That's why when you do a survey, quite often they're asking for demographic data. They want to know what part of the population you represent. So they don't generalize you and your response to the entire population. Oh, you represent white females who are 22 years old. Okay, that's good. We wanted to know what white females who are 22 years old think about X. But white males, maybe not. Black males, black females, people who are older. So if people who are older really, God, people who are kids are nightmarishly difficult to survey. They don't have the damn time. So you've really got to pay close attention when you're figuring out your results to non-response rate. Really crucial. And am I going to beat it to death? Yes, it's so important. Okay, cross-population generalizability is also always a question. How do you increase it? Study the typical over the convenient. What's the problem here? Duh, you don't know what's typical. If it's really well researched and you're adding to the research, then you have a good chance of knowing what's typical, and then you study the typical. But studying the typical over the convenient means it's inconvenient, which means it's harder, which means it's more expensive and more time consuming. Are you going to do that? Always a question. Perform multi-site studies. So, you could, in our study of commercial building developers and building energy efficiency into them, we just did Northern California. Suppose we did Southern California and got different results. They love energy efficiency and they're building, okay, then our results are kind of crap. They only apply to Northern California. Suppose we go to Southern California, and this is a 20-year-old study, but I wouldn't be surprised if the results were the same now. We go to Southern California, the same thing happens. It's the developers who don't want to build it in because it won't make them any money. That was more or less our results. Okay, if we find it in Northern California, around San Francisco, Sacramento, Silicon Valley, then we go to LA and Orange County and Inland Valley and San Diego, and we find the same results. We might just find the same results in Chicago and Houston and New York City. That would be multi-site studies. That increases your confidence that you can generalize beyond those whom you studied. And it's finally very important to point out that some researchers aren't looking for generalization at all. They don't even care about sample quality. They just know they've studied some people, and those people exist. They're part of society. Their story deserves to be told, even if they are not typical, even if they're weirdos and marginal. You know what? They have a right to live. They have a right to have their stories told. They have a right to be researched like everybody else. It says something about society that they exist. So sometimes you can talk about sampling and not really worry about generalizability. Most people do. Most researchers are always concerned with generalizability. And some, they aren't concerned with it. And that's okay. All right. I think now that I've been through all of this, you can see the problem of studying a part of a population and how careful you have to be in your planning to make sure you're learning about all of it. I will be on ReggieNet forum, starting with a new conversation or a new forum called Sampling 19 Sampling 2 at 12:30. And if you want to show up with questions, I'll be there. See ya.